Okay, so welcome to this difficult GCSE Physics question on energy. So we're going to read through the question first of all. So it says a pendulum of mass 200 grams. Now, if you've learnt your energy equations before, you know in physics we tend to deal with kilograms and meters. So that's going to require conversion later on. So I'd really strongly highlight that in the question. It's pulled horizontally sideways by 30 centimeters, and again, that should be in meters, so we are going to do a conversion later on. The length of the string is 50 centimeters. Again, look at that unit. So calculate the potential energy of the pendulum in this position. Assume G equals 9.8. So they've told us potential energy, gravity, so that we're looking to use the equation gravitational potential energy equals mass times gravity times height. That's the only equation on the syllabus that fits that criteria. So that's a help in selecting the correct equation. This one's a little bit more complicated than that. And will require you to know your GCSE maths lessons on Pythagoras. So let's have a look. We've got the pendulum here, it swings. So logic tells you if the pendulum was up there, that would swing down to there. The pendulum would be there at the start. At the end, it will be there. And so helpfully, on this diagram, they've given us a bit of a clue that we will be needing to calculate the distance OP. It's a clue there in the question mark. But actually the height raised is this distance here. If you think about it, pendulum started at this low point, swung out here to a point that's higher up. Okay, and if you think about it then, that height there is going to be this 50 centimeters, take away this one here. So as a starting point, how are we going to do this? Well, we're going to remind ourselves of Pythagoras' theory, which is in a right-angled triangle, the square of the hypotenuse is this distance O to A, is going to equal the square of the adjacent and the distance OP and the distance AP. Okay, so let's write out the equation then. We've got OP squared plus PA squared is going to equal OA squared. So that's the equation that we've got. And so we're going to have to rearrange it to work out the distance OP. Well, how are we going to do that? Well, whatever we do to the left side of the equal sign, we must do to the right side of the equal sign. And when we do that, that cancels. And so OP squared is going to equal OA squared minus PA squared. Okay, so let's look into that. Sub the numbers in. So OA squared, 50 squared, minus PA squared, 30 squared. That's not turned out very nice. It's going to equal OP squared. So let's calculate those. So 50 squared is going to be 2,500, minus 30 squared is going to be 900. So when we take 2,500 away, you should always do this on your calculator, we're going to be left with 1,600. That is OP squared. So what we have to do to get OP is we are going to square root that, folks. And when we do that, we get 40 centimeters. And that's part of the way through this question. Okay. So next bit is to understand that if this distance is 40 centimeters, then the pendulum down there is 50 centimeters, then when we've swung out here, basically the distance, could do with another letter here, but this distance here is going to be 10 centimeters, folks. And that's the height we're going to use to put into this equation here. Okay, 10 centimeters. All right, so let's do that stage now then. I've got to say this is an awful lot of work for 2 marks. But there we go. So, gravitational energy. What's the mass in this question? Well, the mass 200 grams there. However, 200 grams is the wrong unit. It needs to be into kilograms. And we know that 1,000 grams equals 1 kilogram. So we have to divide that by 1,000. So that's 0.2, folks. We'll go into that. Times by gravity, it's given in the question as 9.8. Times by the height, 10 centimeters. But again, how many centimeters in a meter, folks? There's 100. So 10 centimeters in a meter, we're going to divide that by 100, folks. That's going to be 0.1 there. So times by 0.1. Okay, so just stick those numbers into the calculator and multiply them all together. Come up with a figure of 0.196. And the unit there is joules. Okay, and so that's your answer.